Okay, so comets then, absolutely fascinating topic, the near-Earth orbits, near-Earth objects, threats to Earth topic. And this whole question was worth 9 marks, so this shows you how well you've got to know every topic. Because if you don't get many on this question, then 9 marks could be the difference between a grade. Okay, so really make sure that you revise well, you revise thoroughly. So anyway, which part of the orbit can be seen and why? So this is the first mark, and y is going to be the second mark. So make sure you pay attention to how many marks and try and guess from the question what the mark's going to be. First point then is that it can be seen near Earth or near the Sun. And actually in a comet's orbit, near Earth is near the Sun, and it's vice versa, so the same point really. Why is that? Because they don't emit light, they're actually illuminated by reflecting the light from the Sun. The other point you could make here is that actually it only gets this tail, the comet gets tail when the Sun heats it. One of the main constituents of a comet is ice, and the Sun's heat actually vaporizes some of that ice, and therefore you get this tail out the back, and that's part of why it's visible. Comet's speed changes during its orbit. Describe the shape of its orbit. Well, it orbits the Sun, and some of you thought it orbit Earth. The shape is elliptical, and it's elliptical like this normally. Okay, so the shape, the first mark is elliptical. Double L, and you could show that it's elliptical either in the drawing here or in the written answer there. It's not oval, you can't say oval. Okay, and how does its speed changes? Well, it's fastest here and slowest out here. Many people thought it's fastest whenever it changes direction. Okay, it's fastest near the Sun. Well, why is that? Well, all of space, everything moving in space is because of gravity. And actually, the gravity is almost enough. Well, near the Sun, gravity is greater. Okay, and that's why it speeds up. You can also say here it's got greater kinetic energy near the Sun as well. Okay, last little part of this one. What might actually happen? This is a bit of a funny one. Why is it difficult to scientists to observe these near-Earth orbits? One of the most obvious answers that most people got was that they are very far away. So, near-Earth objects are actually very far away. It's difficult for them to see because the distances are so great, and also you could have said they are so small. Okay, now, one thing that we could do if we did discover an NEO which is on the course to Earth, we could send a missile to intercept it. Good thing, bad thing, and one of the points is it's a long-range missile. So a good thing, well, yeah, it could hit the Earth. Okay, it's not good enough. It could hit the object. That's not good enough. It could explode the object. It's not good enough as well. It could break it up. You could say into small pieces, into smithereens. Okay, fragments is okay there as well, and then basically those fragments, they won't hit the Earth because they will burn up in the atmosphere. Suddenly you get a lot of friction, it gets very hot as it enters the atmosphere, and they burn up, and we get very, very small pieces, if any, landing on Earth. They are the adds, the disadds you could have, and you could basically any three from this little list I'm going to give you. The point is it might miss, the missile might miss. And actually, see how it was a long-range missile? It could be an advantage that if it misses, you might still have another chance to hit it. So there's a point there you might wish to make. You could have had that for a mark. If it's very large though, it might not have an effect, it might not deflect. The asteroid, the comet. Okay, it might not break it up in smaller pieces. And another disadvantage you could say is that smaller pieces could still hit Earth. They could still be big enough to get through the atmosphere, so on and so forth. So there's loads of ways you can get marks here, but they're the sort of common ones.